during the majority of your flyby. Did you notice any time when the brightness of Earth began to change your view of the moon's brightness? And can you describe how your perception of the moon's color changed as the Earth came closer to the moon?
Yeah, absolutely. And essentially, as soon as the Earth became in the view, the easy view, where I didn't have to turn my head, when it was in what I'll call my field of view, not my field of regard, when I could just see it looking straight, the moon was already at a point where I was losing subtle albedo differences. I think it's the angle of incidence. The angle, the sun to the moon didn't change much, but we moved to the side, so we were seeing a different angle, and the color was less apparent. Oriental had also rotated really close to the limb, so a lot of the features that I was looking at were moving away, but I think the change in lighting was due to the angle of incidence, but then when the Earth became apparent, its brightness, it was so bright. It was so bright it looked out of place. The gray of the moon and the black of space kind of seemed to go together, but then more in the dull sense, but then the vividness and brightness, like the difference between an LED display and a painting, right? You can just do things with light that you can't do with paint colors. The Earth looked out of place, and it just continued to dim the albedo and color that was earlier apparent in the moon. I'm passing to Christina.
You saw me nodding vigorously back here. That wasn't just my fantastic listening skills. I was nodding to make sure. Oh, we're not on video. This whole time I've been putting on a show. I was nodding, now you know, because I agreed with everything he said. I'll add a couple thoughts that popped into my mind, which was, I think I made the comment that the moon turned into a sponge of light. In my mind, before the Earth came into view, the moon actually was reflecting light, and it was lit up. As soon as the Earth got close enough to be in my field of view to take them both in at the same time, exactly what Victor said, it dulled, it turned into a sponge. It's almost like it went matte.
Next question is for all of you. Ohm crater was observed by all four of you, and we're interested in whether your different viewing angles resulted in how you observed Ohm. Jeremy and Reed saw it first. Were you able to see the ejecta rays, the central peak? And then Christina and Victor, you were next, and you observed Ohm later in the past. Could you resolve similar or different features than what you're about to hear from Jeremy and Reed?
The ejecta blanket for Ohm, I mean, it definitely changed as we went around the moon, but it did not change that much. It was always there. It was always fairly apparent. What is more apparent than the ejecta is the brownish gray, darker area that makes the 12 o'clock to 3 o'clock cut of the pie shape. Like that was always very apparent, and the ejecta rays just made that contrast much more apparent. But overall, Ohm did not change drastically as we went around the moon, unlike Oriental, which drastically changed as we went around the moon. And I'll keep going there. And I'm kind of going to read this question, but it was later on in the orbit that I noticed the ray of Ohm, like the primary ray of Ohm that comes out of roughly the 3 o'clock position, was on the Mare. And I'm not sure if I was picking that up initially in our first observations, but definitely in the latter. Did you notice that at all? No, the near side Mare, yeah. Yeah, Reed says he was noticing that the whole time. That might have been more noticeable to me later on, but that would be the only delta.
Now this view inside the SIR, the Science Evaluation Room, you can see this team of scientists taking a look at one of the photos that the crew shared. And you can see the photos from the crew at images.nasa.gov or by visiting NASA's social media. That's at NASA or at NASA Artemis. You're now looking at a live view outside the Orion spacecraft, the solar array wing positioned to look at the spacecraft itself. This is Artemis Mission Control at Johnson Space Center in Houston, Texas. The voice you hear on the ground is Capcom and NASA astronaut Stan Love speaking with the crew aboard Orion, specifically Canadian Space Agency astronaut Jeremy Hansen. We are targeting the RTC-1 burn today. That's Return Trajectory Correction 1. That is targeted for about 7:03 p.m. Central Time. This is a small burn using the Reaction Control System thrusters on the service module of the Orion spacecraft. This helps us fine-tune our path back home. Stan Love was letting the crew know that we are canceling their first preliminary burn targeting conference. They have another one of these in a couple of hours when they will have the final burn plans uplinked and the final targeting complete. Here's a video from the outside of Orion, and as we mentioned, pilot Victor Glover is exercising. We do see the spacecraft move a little bit when the crew is exercising, and so the teams here park the solar arrays into a safe harbor position. That means any motion that they experience due to the exercise doesn't damage the solar arrays. You're looking at a visualization of the spacecraft. Now 48,670 miles from the moon and 228,090 miles from Earth, continuing to grow closer. You can keep up with this data at any time by visiting nasa.gov/track-Artemis.
Down and to the left, line 17, the DAP load is 3 for burn maneuver.
Go ahead.
In the guidance solutions section, the delta V tote now 1.4 feet per second. The TGO is unchanged at 15 seconds.
Good, go ahead.
Attitude, yaw 154. Pitch 26. Roll 287.
That was Capcom's Stan Love here in Mission Control Houston, a fellow NASA astronaut speaking with NASA's Christina Cook aboard the Orion spacecraft. The crew aboard the spacecraft is preparing for their return trajectory correction burn. It's the first of these return trajectory correction burns, reported to be at 1.4 foot per second delta V burn. Such a fantastic view coming from a solar array camera on Orion, looking back at all of us here on Earth. Currently, the spacecraft is 227,756 miles away from our home planet. Orion is now 49,168 miles away from the moon. Earlier today, the spacecraft exited the lunar sphere of influence. That's when the pull of gravity is strongest on the spacecraft. And we are standing by for the return trajectory correction 1 burn, now just 43 minutes away. Again, this is a small maneuver for the spacecraft, firing of those reaction control system thrusters.
And integrity, MCC is go for the burn.
Okay, we copy. You're still go. Then we're go up here.
Ground team confirmed that we are go for the RTC-1 burn, return trajectory correction 1, coming up in 27 minutes. That will be at 7:03 p.m. Central Time.
Integrity, tank pressures are good for the burn.
Standing by for the RTC-1 burn. We have ignition and 4 good engines and good control.
Integrity, preliminary look is a good burn. Still assessing, 40 seconds to LOS.
Okay, Stan, we saw a good burn on board as well.
Roger.
Confirmation from the crew that they also saw a good return trajectory correction 1 burn, coming at 7:03 p.m. Central Time. This view coming from the spacecraft, looking down at the European service module and the solar arrays. This is Artemis Mission Control. We did get final confirmation of that return trajectory correction 1 burn being a successful burn, and it ended up being 1.6 feet per second delta V. We are in a forward link LOS, or loss of signal, and the crew aboard the Orion spacecraft is, Christina Cook specifically, is going to get into some exercise. Again, this is a quiet day for the crew as they had a very busy day yesterday and have some busy days coming up as well.
And Reed, we just went around the room.
Oh.
We are all good. You can begin exercise now if you'd like.
Okay, we will. It is pretty interesting up here. I'm sure you see it in the data, but we can definitely feel the vehicle moving around when folks are exercising. It's pretty cool to just sit there and float and feel the vehicle kind of. It's not like a ship rocking in the ocean, but you definitely feel it wiggling around.
We also see it in the SAW video as well as our data, but good to hear your report on it as well.
Hey, one last question. This is for a little later tonight, but we kind of want to do a couple deep sky long exposure photographs. If the saws are in the windows and it's possible to get the lights turned off on the SAW cameras in about an hour, we might appreciate that, but clearly not if it interrupts any sort of ops down there.
Reed, we think that will be doable. We will double check and we'll let you know when you're done exercising.